Hey, hi. Good morning, everybody. Yeah, hope I'm audible. I'm sharing my screen. Once you're able to see the presentation, just say yes in chat box so that we can start. Yeah. Okay. Yeah. Thanks. Yeah. Happy morning, Dilip Kumar. Okay. Fine. We are in the fifth class on chemical safety. Yesterday we have seen the safety requirements with respect to handling of uh, chlorine, ammonia, as well as LPG and also ethylene oxide. Okay. So today we're trying to cover a few more topics with respect to chemical safety. So by starting with, we'll see today the process hazards and controls. So if it comes to a process hazards, there are two kinds of processes. One is in a batch process, other one is in a continuous process. So if you see the types of process and operations, generally the chemical plant process are classified as batch and continuous or their combination. Sometimes what will happen, they'll have combination of both. Once if you see the both processes are relatively more manpower is required, then the workers are exposed to the hazards more frequently, and the process automation and instrumentation are possible only to a limited extent. And the continuous process is carried out in a closed vessels and circuit or good automation and instrumentation are possible, and many processes are operated at high pressure and high temperature, as in case of petroleum and petroleum chemistry or industry, for which automatic warning, monitoring, controlling devices are designed. It is simple that if you see any chemical process, basically what we'll see, people are more aware about the chemical process. So definitely they have reactors, they have centrifuges, they have filtration. All these are works under certain pressure. So which are in high pressure conditions, they used to work. So this continuous operation happens in a closed vessels. The closed vessels in the sense, the chemicals are contained in a circuit. It is not going to expose. A closed vessel means you can't able to the vapors will not be released openly. It is a closed, contained operation. Like I've taken yesterday's night example as a pressure cooker. So the pressure cooker, the cooking activity, the cooking process, which is happening inside the vessel, it is also a closed vessel or a circuit, we can say. అంటే ఏంటంటే ఇక్కడ అన్ని కూడాను మూత పెట్టి చేసే పనులు ఉంటాయి. సో ఎప్పుడు కూడాను ఈ రియాక్షన్ జరిగేటప్పుడు దాని ద్వారా వచ్చే వేపర్స్ కానీ వాయువులు కానీ గ్యాసెస్ కానీ బయటికి రిలీజ్ అవ్వవు. బట్ డెఫినెట్లీ దెర్ ఇస్ ఏ సేఫ్టీ కంట్రోల్ వాల్వ్స్. Those valves are used to release the excess pressure of the designed excess pressure to release on the as per the design parameters or also working parameters of the equipment. And also, as we seen, because these equipments are working under high pressures, so definitely they should have a certain kind of alarm and warning systems in place so that it can alert the humankind, so that the people will alert and they will control the systems. And pressure and temperature should be properly controlled by the cooling and safety devices, which are flammable explosives and solvent distillation processes should be carried out under the inert atmosphere, or a vacuum or toxic process should be connected to the appropriate scrubbers. So if we see flammables, explosives and solvent distillation processes, these are explosive in nature. They are fire in nature. And Monday swabhavani kaligi untayi. So what in chesamu, will do these kind of operations under inert atmosphere. What is mean by inert atmosphere? If it is an inert atmosphere where the flammable mixture will not be happen or will not generate. That's why we'll use this inert atmosphere. Basically, they use the nitrogen to create the inert atmosphere so that the nitrogen will not allow to create a flammable mixture. And vacuum, sometimes we'll do in a vacuum also. So if it is in a vacuum, there is no air at all. So that what will happen? Automatically, the fire will not initiate. And if it is a toxic process, so అంటే మీ ప్రాసెస్ ఏదన్నా టాక్సిక్ అంటే విషపూరితపరమైన రసాయనాలు ఏమన్నా చేస్తున్నప్పుడు there will do appropriate scrubbers and neutralizers. It is not mean that for the flammable and explosive, the scrubbers will not be there. Sometimes some kind of chemicals, they are mix of flammable in nature and also toxic. So for those kind of operations or processes you are doing, there you will have inert kind of atmosphere, as well as you must have scrubber and neutralizer systems in place so that we can control both the kind of emergencies. Study all unit processes, arrive unit operations with a complete reaction document. We have to read all the process related documentation before starting up a reaction. That is all the reaction data of intermittent behavior as well as the escaping behavior out of the control parameters. And there requires a precise laboratory study and also much details of side reactions and unwanted runaway reactions, generation of flammable or toxic vapor, fumes, etc. So before starting of any process, we should understand the nature of the chemicals. So the behavior and also escaping behavior of the gases which will form, and also controlled parameters, which means the pressure, temperature, the quantities, etc. And also requires the lab study. So that's why all the chemical industries, they have the R&D centers. They do a sample analysis on a limited quantities of the chemical. Then they will go for a bulk production. As we mentioned, the unwanted runaway reactions also we have to understand. We must understood the side reactions. So once I starting my reaction with the chemical A, B, and C. So once after mixing A and B and C, there may be unwanted reactions which may come out from my activity. So we have to understood what kind of side reactions can happen and unwanted runaway reaction. The unwanted runaway reaction is nothing but exothermic reactions. Unwanted runaway reaction. So it will happen on seconds. It will increase the temperature very rapidly. అంటే ఫాస్ట్ గా టెంపరేచర్ అనేది పెరిగిపోయి మనకు అక్కడ ప్రెషర్ బిల్డప్ అయ్యి అక్కడ ప్రమాదం జరిగేదానికి ఛాన్స్ ఉంటుంది. Then generation of flammable and toxic vapors and gases, etc. And all the generation of abnormal pressure, temperature, and expansion, contraction, etc. At any stage of the process, it is controlled out of the control, adversely affecting the people and environment. As I mentioned, whenever unwanted reactions or unexpected runaway reactions happens, these are the results or the outcome of the reaction. Maybe it releases flammable or toxic fumes, gases, and also abnormal pressure. My reactor is designed for 2 kg per centimeter cube, but the reaction, it is producing more, or it is giving 5 centimeter per square pressure. So automatically what will happen? It will get pressurized, and then weak portion in the reactor, it can explode. So we have to understand all the aspects with respect to the reaction process so that we can lead the process in a safer manner. So based on understanding all these issues, like how side reactions happens, or is there any chances of unwanted runaway reaction? If there an unwanted reaction happens, how I can control it? And in case of any abnormal pressure it creates, so what is the limit of that pressure? And also temperature, any expansion, contraction happens in the vessel, all these things has to be considered. అంటే ఇవన్నీ కూడా మనం కన్సిడర్ చేయాలి. టెంపరేచర్ కానీ, ప్రెషర్ కానీ, ఇంకేమైనా ఎక్స్పాన్షన్ అవుతుందా, కాంట్రాక్షన్ అవుతుందా, ఎటువంటి గ్యాసెస్ రిలీజ్ అవుతున్నాయి, ఫ్లేమబుల్ గ్యాసెస్ రిలీజ్ అవుతుంది, ఇన్ కేస్ అబ్నార్మల్ టెంపరేచర్ కనుక పెరుగుతుంటే దాన్ని ఎలా కంట్రోల్ చేయాలి? బేసికల్‌గా మనకి రియాక్టర్స్‌కి జాకెట్స్ ఉంటాయి. అందులో మనం చిల్డ్ వాటర్ గాని, కోల్డ్ వాటర్ గాని, బ్రెయిన్ అంటాము. బ్రెయిన్ వచ్చేసి హైయెస్ట్ మైనస్ డిగ్రీస్ వి కెన్ టేక్ ది టెంపరేచర్స్. అంటే ఇవన్నీ యూజ్ చేసి మనం దాన్ని కంట్రోల్ చేయొచ్చు. All necessary safety measures must be kept ready and also provided to keep the reaction in control, to control again in the event of their going out of the control also. And the process of exothermic high pressure reactions, solvent distillation, distillation of toxic substances, polymerization or chain of reaction, gas generation, filling, etc. And petroleum processing, autocatalytic reactions or decomposition, undesired reactions are under media and also operating in order to explosive range, the process of combustible materials, also the process of toxic materials, dust, fumes, process gas, difficult to control, need much attention. Don't get confused. I'm running with the words which are, it is simple that in case of any exothermic reaction or high pressure reaction happens in distillation process or any toxic substance or polymerization or chain of reactions or undesired reactions any happens in the media, there we need a difficult to control, need much attention. So any these kind of operations happens, there it is very hard to control. So that we should have proper control mechanisms in place. Auto cut off temperatures, auto activation of cooling systems in place, then pressure relief valve, indication of the pressure gauges or pressure indicators and alarm systems. All these systems should be in place in case there is a chance of exothermic reactions happens in your process. I will say what is mean by reaction rate. The reaction rate must be controlled. The reaction rate is determined by the rates of the forward or reverse side reactions and by the rate of diffusion of the reactants, the intensity of heat supply, mass transfer coefficient, and rate of constant of the process, driving forces of the process, pressure, temperature, catalysis, mixing or addition, stirring time, etc. So reaction rate and how fast you can able to complete the process or you can complete the reaction. Reaction rate is nothing but it is the speed of the completion of the chemical reaction. So what and all will affect on this reaction rate? One is supply, transfer of the materials, and driving forces like pressure, temperature, and catalysis, mixing, addition, stirring. All these are the parameters where it can differ the reaction rate. And some of the important parameters to be controlled. One is heat, material and energy balance must be understood properly. To maintain proper reaction rate, for example, if I start mixing of two chemicals, so if I want to increase the reaction rate, either I have to increase the pressure, I have to increase the temperature, or I have to increase the stirring time. Like that, we have to understand the process to manage the reaction rate. In practical terms, 10-degree temperature rise may double the reaction rate, and the reaction heat tends to accelerate the reaction and leads to a runaway if the cooling system is inadequate or fails suddenly. So in some cases, a 10 degrees of increase of temperature, what will happen? It can double the reaction rate. Means, for example, the reaction has to happen in 10 minutes at 10 degrees centigrade. If the 10 degrees centigrade it is given, what will happen? It can happen in the 5 minutes because of the temperature, the chemicals will behave differently. Automatically, it will double the reaction rate. Instead of 10 minutes, it will happen in 5 minutes. Like how fast food happens. That is not so healthy for the people to consume. The similar way, instead of it is supposed to happen in 10 minutes, it is happening in 5 minutes. So there, the amount of heat generation is high, the pressure is high, and also we can't able to control also. If you are not able to control, what will happen? It leads to runaway reaction resulting in accidents. When it happens, if your cooling systems are not adequate or it is not in working condition, at the time of reaction process. And many accidents have been noticed in such cases. In oxidation of hydrocarbons, nitration and also polymerization are some typical examples. And this oxidation process of hydrocarbons, nitration and polymerization are some of the typical examples for these exothermic reactions. Now we'll see what is mean by the unit processes. So if you see, this is the typical reactors you can see in a chemical industry. 1 second. Yeah, like water reactive chemicals. Correct. Yeah, Dilip. So if you see a typical unit processes, alcoholic caustic fusion, which is the reaction carried out at the low temperatures using the caustic soda and potassium alcohol. Amination, introduction of amino groups into the molecules using liquid ammonia, and caustic fusion, a reaction carried out in a molten caustic potash or a caustic soda temperature. Condensation is, I mean, everybody knows this. So there we rise the temperature of the liquids, then we can cool down the vapors, and then we'll extract the material which we want. Reaction in which two or more molecules combine in the separation of water and simple substances. Hallucination, introduction of chlorine or bromine into the molecules using calcium hydroxide, and hydroxylation, introduction of hydroxyl group in molecule using the calcium hydroxide. Then nitration, oxidation, reduction, sulfonation. These are also some of the unit processes. Okay. If you see some of the hazards associated with the unit process, and also which are the industries which is applicable, or which are the industries these kind of hazards will present. You see alkylation, example, butyl plus isotone, isobutene and isooctane, where the process hazard is exothermic and side reactions. Basically, this happen in petro and organic chemical manufacturing. And animation by aminolysis, a gas phase, a pressure reaction, and also exothermic. This happens in dyes and organic chemicals and synthetic fibers. Ammoxidation, which is also an exothermic and toxic effects. And carbonylation, which is also having exothermic. If you observe, so most of the process hazards are exothermic. Exothermic in the sense where an uncontrollable heat will generate in this stage. So where we should have proper cooling systems in place in a proper working order to manage the situation. Otherwise, it will resulting in accidents. Then hydrolysis, again exothermic, and nitration, it is highly exothermic. Oxidation, it is highly exothermic. Polymerization, it is also highly exothermic, and sulfonation also exothermic. So all reaction process or unit process we have, exothermic reaction is the hazard. Now, if you see a hazard associated with the unit processes or operations, one is mechanical hazards, which is of pressure release, leaks, burns, noise, equipment, or any utility failures with respect to mechanical hazards. And with respect to reaction hazards, due to failure to control exotherms and incompatible materials, side reactions, and feed ratio or rate variations. Then if you see environmental hazards, what will happen from the chemicals? Definitely environmental pollution, that is the major, then odor, smell issues, spillages, which resulting into the land pollution or contamination of the other materials. In toxicity, health effects, flammability hazards due to the explosive mixture or static charge, and also auto ignition temperatures or auto ignite materials. These all are the hazards with respect to unit processes. Now, if you see unit operations, so in such operations, there is no chemical reaction to form a new product. It indicates no chemical change, but mechanical or physical change like distillation, cutting, heating, cooling, drying, mixing, grading, washing, packing, or transferring, filtering. So that is the major difference between unit process or unit operations. In process, what will happen? Where the chemical reaction happens, there you will form a other chemical. But in the unit operations, what will happen? It will only convert the physical properties of the material, like from liquid to solid, and also controlling the temperature, and liquid to solids, and also washing, packing, etc. Here, there is no change in the formula of the chemical. Some general operations in a sequence of following. One is steam distillation, where the live steam is passed into the still to recover the solvents. So here what will happen in steam distillation? We use steam as a heating element. We'll apply it on the solvent so that there will recover the materials. The vapors of the solvent and also the water are passed in a shell tube type and also condenser and also cooler. Then the cooled distilled taken into the separator where the solvent or water separate out and also diverted to respective storage. Like how we'll do a petroleum distillation, where we have a distillation column, we apply heat to the crude oil in certain levels and certain temperatures. All these materials are segregated. Then heating. Heating operation can be done either by directly or indirectly. In indirect heating, a steam is passed in the material directly to heat the material. In indirect heating, heating media, example, steam, hot oil, or hot fumes or gases passed in the jacket or oil of the vessel. So jacket in the sense, basically what will happen if you're already in chemical industry, you'll be known. For example, if it is in a vessel, outer that we will have a jacket. So outer area. So in this area, you can apply the whatever the element we want. So it will heat the vessel or it can cool the vessels. This is used. So here we use this for cooling of the vessel and also heating of the vessel. Both ways we can use this jacket. Direct heating is you are directly applying heat on the material. Indirect heat means where you are applying heat on jacket so that it will indirectly affect the material inside the vessel. Then cooling. Cooling also same. It can be done directly or indirectly. In direct cooling, ice or cold water is added to the material. Directly or indirect, we will apply on the again jacket or the coil. Then drowning means transferring reaction mass from the reaction vessel to a tank which is containing a water or other medium which is dilute or acid. And this operation is separating solids and liquids, and also the conventional items used for this operations are press, notch filter or centrifuges, and also filtration units, etc. Here what will happen? We will filter the materials. How will we filter the materials? For example, if you take a slurry kind of material, like almost like a toothpaste, you put it into the centrifuge. Centrifuge, what will happen? Inside there will be a filter bag. You put all your slurry in that. So what will happen here? It will rotate in 1,000 revolutions per minute. So due to that speed, whatever the liquid particles which are there in the slurry, it will be segregated out. Then pulverization. This operation is done to reduce the size of the material. Usually crushers or pulverize or ST mills are used. Pulverization is nothing but reducing the size of the materials. Like ante manam pinti daggara pindu marinchukuntam kada, that is also a pulverization activity. Then blending. This operation is done in a blender to mix thoroughly 2 or more dried products. And washing. This operation is done in a press, nutches or centrifuge to remove the soluble impurities and acid or alkali from the product. Then packing. It is filling up of the finished product in a containers. Storing of liquid raw materials. It is also a storing kind of activity. The bulk liquids or raw materials which are received in the tanker, loaded or empty, out the storage provided for the purposes. It is simple that storing of chemicals which we have received for our operations. Then unit operations. Unit operations are classified into different types. One is mechanical unit operations. One is size reduction or size enlargement, mixing, agitation. Agitation is mixing, both are same. Blending or kneading, and also separation. Example, gravity settling, filtration, centrifugal, in pigments, screening, jigging or magnetic electrostatic, hydro, and also flotation. These are the other kind of unit operations. And so if you see a mass transfer operation, evaporation, distillation, absorption, humidification, and also extraction, leaching, crystallization, ion exchange, or also absorption and drying. These are the some of the activities will happen in the mass transfer operation. If you see a heat transfer operation, we'll do a conduction, convection, and radiation. What is meant by conduction? The conduction is the direct transfer of the heat from the molecules. Like if you take an iron rod, if you heat up from the one side, automatically the other portion also will get heated. And convection, it is kind of a liquid activity. So where the bottom and also it will transfer the liquid. In radiation, it is happens to the hot waves. Once I put a flame in this location, there the hot wave will generate. Due to that hot wave, it will get reacts or to get heated up the adjacent materials. Then material handling, transportation, and also convenience. So these activities happens pumping, compression, fluidization, and also containerization or solid filling. These are the some other activities will happen in the unit operations. Then controls. With respect to controls of this unit operations, what kind of controls should be in place? If you see a distillation operation needs a trip and alarm devices to stop the heating as soon as the cooling stops. So distillation means what? Distillation means if you take a crude oil, when we do a distillation, in the sense, we apply heat to that crude oil. So in certain levels or certain temperatures, the chemicals which are there or the materials which are there in that crude gets separated.